Howdy, everybody. We have already made it to our last lesson of the chapter. So, without further ado, we are moving on to trapezoids and kites. As always, we're going to learn some properties about these polygons and then use those properties to find either missing angles or side lengths, okay? Oh, of course, this is the time I don't have my little... Okay, hold on. 1 second. Okay, I don't know why this one isn't in our notes, but if we had our little concept map that we've seen a bunch so far this chapter, we have quadrilaterals, and we've been focusing on parallelograms for the last few lessons, right? And now we're finally going to move to non-parallelogram. So that's where our trapezoids and kites stem from, okay? So we're now finally on this non-parallelogram side. Okay. So let's talk about some properties of these trapezoids, okay? So we have two different types that we're going to focus on. We have non-isosceles trapezoids and isosceles trapezoids. Let's first talk about non-isosceles trapezoids. So, big thing with a trapezoid, we only have one pair of opposite sides parallel. That's why it's not a parallelogram, because we don't have both sides that are parallel, just one pair. So that's why we get the little triangles right there, because those two sides are parallel. And then the other big property is that consecutive angles are supplementary. So like these guys here, the ones that are on top of each other, those guys add to 180. And these guys add to 180. And that's kind of like all we really care about for a non-isosceles trapezoid. Now, for an isosceles trapezoid, think of an isosceles triangle. An isosceles triangle has two legs the same, right? There are two legs that are congruent. Well, that's why we have an isosceles trapezoid, because our legs here are equal. So maybe you guys want to call that. So the two sides that are equal, we call our legs. The top and bottom that are parallel are called the bases. And then we have these things called base angles. We have a pair right there. Those guys are base angles. And then, do I have another color here? Sure do. And these guys up top are also called base angles. Okay, so just to reiterate, our non-parallel sides, so our legs, are congruent. That's why we have those tick marks. Our diagonals are congruent. Your different pairs of base angles are congruent. So this angle right here is congruent to this angle right there, our base angles, as with this one being congruent to this one. Opposite angles are supplementary. That's a fun fact. Well, that's because still here, these guys still add to 180 as well, those consecutive angles. Okay, a lot of info. Again, it'll become more concrete once we try with some examples, okay? So let's start with some pretty basic ones. It says find the measure of angle K and M. So easiest thing here to find angle K, these guys add to 180, right? So we just simply subtract away. So 180 minus 51 should give us 129. Same thing with angle M. Those guys add to 180, so subtract away. So 180 minus 87 is 93. Pretty basic, right? Then, of course, let's throw in some algebra just to work on those skills here. We're looking for the measure of angle R. So in order to find that, we have to figure out what X is. We know that those two guys add to 180. So I'm going to kind of do two steps in one. I'm going to add my like terms right away. So 12x plus 7x is 19x. 3 minus 13 is negative 10 equals 180. Add over that 10. 190, divide out, x equals 10. Now we plug in So 7 times 10 minus 13, 70 minus 13 should give us 57. Okay, doing all right? Okay, we are told we have an isosceles trapezoid DEFG, and we are just kind of matching, okay? That's all we're doing. So what is DG? This would be a leg. What does DG match? Well, it would match its other leg over here, EF. Those guys are congruent. DF, this diagonal, is congruent to our other diagonal, which would be GE. Looking for some missing angles in this isosceles trapezoid. Again, how did I know it was an isosceles trapezoid? My legs are congruent. So remember, base angles are the same. So angle X and angle W are the same. So if this guy's 47, so is W. And then to simply find either Z or Y, we know that these guys add to 180. So subtract away, 133. And you can think if Y is 133, so is Z, because these guys are also base angles that are equal. And if you forget that, same idea. If we know that guy's if that guy's 47, we can just subtract from 180. Multiple ways to do this. You do whatever works best for you. Okay, we're going to change gears a bit, and we're going to talk about a mid-segment. So the mid-segment of a trapezoid connects the midpoints of the legs. So if we look at this picture, I know it's kind of hard to see here, but we know this is the midpoint because we have AE being congruent to DE, so E is the midpoint. And same thing over here, we have BF being congruent to FC, so F is our midpoint over there. And the mid-segment connects those two midpoints. It's kind of a nice, easy name to remember. Mid-segment is connecting the midpoints. We love when things kind of go together like that. Okay, so it says if EF is the mid-segment of trapezoid ABCD, then AB is parallel to EF, which is parallel to DC. So when this happens, all three of these segments here are parallel, meaning they're never going to intersect. And then we also have a fun little formula to help us find these measures. So if we were looking for the length of EF, it's pretty easy. All you do is you add the length of AB plus the length of DC and divide by 2. So you take your two bases that they give you, whatever those measurements are, add them, and then divide by 2, and that's how we get the mid-segment. And think about it, like that's how you find the midpoint, right, of two ordered pairs. You take your x coordinates, add them up, divide by 2, take your y coordinates, add them up, divide by 2, and you get the midpoint. Doing the exact same thing here to find the mid-segment. See, math, things always connect. It's just a matter of, are you making those connections? Alrighty, let's try some pretty basic examples here. So we are looking for this mid-segment. Again, you take your bases that they give us, so 7 plus 11, divide by 2. 7 plus 11 is 18, divide by 2, and we get 9. And the best part is you can always check. 7 to 9 is 2 away, 9 to 11 is 2 away. These should be the same distance. Everything checks out. We're good to go. Now this time, we're missing a base, and we're not, and that's what we're trying to find, excuse me. So there's a few ways you could do this. You can either use the formula, or you can simply just skip count. How far away is 16 and 10? Well, they're 6 away, so I need to go 6 more away. So 10 minus 6 would give me 4. That's one way to do it. If you're more formula-based, you just plug in your variables, what you have. So we know 10 is going to equal our bases added together divided by 2. How do you get rid of divide by 2? You simply times by 2. I want to get x alone, subtract over 16, so we should get x equals 4, and that's what we wanted. Again, you do you. I probably would have just counted the difference and did it this way, but it's always nice to know that the formula works as well. Okay, same type of problem. We're looking for the value of x given the midpoint, or excuse me, the mid-segment situation. Okay, a little bit more algebra here, but that's okay. It's good for us to practice that. So we know our mid-segment, 5x minus 19, is going to be equal to 38, our base, plus our other base of x plus 14, all over 2. I don't like working with fractions, so I'm going to multiply by 2 to both sides. But remember, when you multiply by 2 over here, you're going to have to distribute that 2 to both the 5x and the 19. So we're going to get 10x minus 38 is equal to 38 plus x plus 14. I should have combined like terms, but that's okay. Not a big deal. I'll do that now. 10x minus 38 equals 38 and 14 is 52 plus x. Bring my x's over here, my numbers to the other side, so we have 9x equals 90. Divide out x equals 10. If that was confusing to you, I promise we'll do one like this together in class. But you're just algebraing your way out of the problem. Okay, folks, and our last quadrilateral that we will focus on this unit is a kite. So a kite is a quadrilateral with the following properties. Exactly 2 pairs of consecutive congruent sides. So that means like the 2 small sides, A, B, and AD are equal, and B, C, and DC are equal. 1 pair of opposite angles are congruent. So angle ABC, this big corner angle, is congruent to angle ADC. So these big corner angles are congruent. And a way to remember that, it's where your 2, like the small side and the big side, connect. That angle is congruent to one it's across from. And then our last property is that your diagonals are perpendicular. So all of those little angles in here are 90. Okay, so we're just gonna start right out of the gate, with finding angle measures. So let's see what we can do here. We know these angles in here are 90, so I'm gonna put 3 down for 90. We know this guy would be 90 as well. So an easy way to find angle 1, right? 180 minus 90 minus 65. 180 minus 90 minus 65 gives us 25. And now, folks, there's just like a lot of symmetry and lines of reflection here. Like this whole top triangle, do you guys see this big triangle here? If you reflect it, if it like reflects down, you get this mirror image down here. They're the exact same. So if angle 1's 25, so is angle 2. If this angle here is 65, so is angle 4. If this angle right here is 52, so is 7. And now an easy way to find 5. Again, we just have another triangle. So 180 minus 90 minus 52 should give us 38. And if 5 is 38, so is 6. Again, if something looks like it's congruent to something else, it probably is. Lots and lots of symmetry, lots of congruent triangles happening. That is why. And then our last example here, we are looking for RZ, given that WX is 14 and WR is 8. And we are looking for this guy right here. So we know that WX is congruent to WZ, so this is 14. We know that our diagonals are perpendicular, so we have a nice right triangle here. So if we do the Pythagorean theorem, we're going to get 8 squared plus x squared equals 14 squared. Crunch out these numbers. 64 plus x squared equals 196. Subtract over that 64, we should get 132. Take the square root. X equals 11.5. And there you have it, kids. We just completed our chapter on quadrilaterals. So as always, thank you for watching and doing your part and making everyone's life easier when we're together. Have a super rest of your day, and I will see you in class. See you later.